Hi everyone, welcome to today's coding session. Today I'll be solving the number of island problem using Python. I will explain the problem. It's constrained in two approaches. The depth first search, also known as DFS. This approach uses recursion to explore each island by visiting all connected islands horizontally and vertically. It marks the visited land to avoid recounting the same island. And we're going to use the breadth first search, also known as BFS. This approach uses a queue to iteratively explore each island layer by layer. It avoids deep recursion, making it more memory efficient for very deep grids. As I code, I'll explain each step in detail, including how to traverse the grid efficiently, how to mark visited lands, why DFS is a divide and conquer strategy, breaking down the grid into smaller connected components recursively, and why BFS is an iterative approach, exploring the grid level by level using a queue. Near the end, I will compare time and space complexity analysis for both approaches. Here, you got a quick view of depth first search, pretty much just going from left to right, all the way, up and down, until it finds every one or every zero that it needs to find. And breadth first search, since it's by level, it's just going to go to B, and just like the ABCs, it's just going to go, once it's done with this level, then it's going to go to the next level until it finds all level and it returns the results. So we are given an M by N 2D binary grid where ones represent land and 0 represent water. We need to return the number of islands. An island is defined as a group of connected land of 1 as such, and they must be connected horizontally and vertically. We don't care about diagonally, so here we don't care about that because they're not connected in that case. The grid is surrounded by water on all edges is what we are to assume, such as here and here. And let's see. And these are two examples of the same, two different output. As we can see, we got one island here, 2 island here, and the 3rd island here, which is the reason why we output 3. Here we got 1 island total because it's connected horizontally and vertically here. So it's only 1 island. So now let's go over the constraint for the number of island problem. The M equals grid length. This represents the number of row in the grid. The N equals grid I dot length. This is the number of columns for each row in the grid. And the grid can have anywhere from 1 to 300 rows and columns. This means that the maximum grid size is 300 by 300, totaling 90,000 cells. Each element in the grid is either 0 or 1. All right, now that we understand constraint, let's dive into the edge cases. So possible edge cases here is, we got single grids. A grid where only one cell, which we have here, or one cell of 0, and I'll output 0 because it's all water. Or a grid only with one cell as land, which is here. So this is land, and this is land, so it's going to output 2. And if the entire grid is water, then there are no islands, which I don't have an example here. And if the entire grid is land, which I also don't have an example here, then the whole grid is considered one large island because all the land is connected. All right, let's move on to brute force approach to solving this problem. So now let's go over the approach from solving a number of island problem using depth first search. So what we're going to do with depth first search is, we will use a nested loop to go through every row and every column of the grid. This ensures that we visit every cell at least once. If a land is found, like a 1, that indicates the start of a new island. We immediately increment the island count since we discover a new island. Perform depth first search to mark all the connected islands visited. We will recursively explore all adjacent land connected to this initial land. So we're gonna go through all the adjacent land. This includes exploring, which will be, in our case here, will be up, which will be out of boundary, down, left, and right, which is the reason I have this right here. Every single time, this is the way we're gonna go. We're gonna go either up, right, down, and left, starting from the place where we find the land. We'll continue until the entire grid is traversed. The depth first search will fully explore one island before returning, and we then continue scanning the grid for more island. All right, let's move on to coding the depth first search. So here, if not grid, we're going to return 0. So here what we're saying is if the grid that we have provided is empty or is none, then we're going to return 0 because there are no island at all. And now let's create a variable to track the number of island. We're going to initialize it to 0. And now let's go through the rows right now. And now let's go to through the column. And now if we find at grid I, grid J, if we find an island, then we're going to increment the count. And we're now also going to call our helper function, was going to be depth first search here. So since this is going to be a helper function, we are going to write it here so we don't have to declare a separate class function. So depth it's going to be I, J. Now we're going to check for the boundaries, make sure that we stay within the boundary of the array given here. So we know that if I is less than 0, if it was less than 0, we're going to return as a way of saying skip it. Or if I is greater than or equal to the length of the grid, we're also going to skip it. So if it's greater than the length of the grid here, we're going to skip it. Or if J is less than 0, which means that is a negative number up here, then we're also going to skip it. Or if J is greater than or equal to the length of grid 0, we're going to do the same thing. If it's greater than, meaning if it's down here, for example, we are going to skip it as well. Or if grid at our current location, ij, equals 0, we're also going to skip that. Because this means that 1, this is water, or 2, we already marked it as water, even if it used to be 1. And here is where we're going to change anything that, so in this case, this will be, let's say it's less than 0, is out of bound, it's true, so we're going to skip it. But in the case that everything here is false, that means that we're going to get a 1, meaning this is a land that we visited. So since we know it's land, automatically the first thing we want to do is we want to make sure to say, okay, well, now we're going to convert it to water right off the bat. And then we're going to check all 4 directions using breadth first search. So this right here is going to look down. And this right here is going to look up, and that's from the current position that we're at now. And then this is going to look right. And this is going to look left. So once we're done with this, then we're going to come back to this loop and we're going to go to the next cell. And once we're done, and we went through the entire grid, meaning we looked through every single one and we marked everything to 0 and we've gone through all of it. Now we return how many islands did we find? Okay, so let's see. So my answer is wrong. So let's see where I went wrong here. Okay. So we got depth first search. So we got grid here equal to 0. And we're going to return it. Grid ij 0. Then, did I just put 1 plus 1? It should have been I plus 1, I minus 1, j. Okay. All right. So this one worked out. And let's see how it compares to others. Okay. So it'd be 68% of other solutions. Took 27 seconds. But it is a very efficient approach nonetheless. It could be better is what this says. And the memory space, let's see. And it uses 27 megabytes, be 66% of other solutions. Okay. All right, let's go through an example problem to see how the depth first search solution works in practice. So we're going to check if the grid is empty first. So we're past this, we're giving this grid. And the first thing we're going to do in the code here is we're going to check if it's empty. In this case, we know it's not empty. So we're going to go here. We're going to traverse through every grid using a nested loop after we already did the island initialized to 0. And the outer loop is going to go through each row, and the inner loop is going to go through each column. So row I is for the row, J is for the columns. So the first land is found at 0, 0, which is here. This indicates the start of a new land. We increment island count to 1. So we found land, we incremented it to 1, and now we're going to go to depth first search at 0, 0 to explore the island. So now when we're here, now we're going to check for boundary. And we're basically going to say is I less than 0, and we said I is row. Is the row less than 0? In this case, no, it's not. It is 0. Is I greater than length? No, it's 0. Is j less than 0? Now it's 0. Is j greater than or equal to greater than 0? No. Greater than the length of the column? No. And is ij equal to 0? And we know that that's not true. So now we're going to go here. So the first thing here is we're marking this grid as being visited by marking it as 0. And then the grid, after we do that, is going to look like this, since we marked it as 0. And we have the neighbors still looking as 1. So then we'll explore all 4 directions from 0, 0. We're going to first go down, and we're going to call DFS here, which is going to be, as you can see, we're going to add 1 to it, which is going to be now 1, 0, which is another land. So we have 1, 0 using this, so we got I, and we added 1 to it, to the row. So now we went 1, and we're at 0. So we'll mark it as visit it, and then we're going to continue with our DFS again. So we're going to come here. It's going to go through all the process of checking the boundaries. Then we're going to mark it as 0, and we're going to go again to the DFS, and we're going to say, okay, well, grid. So we're going to go again to the row here, and we see this as 0. So when we go here, it's going to return because it's 0. It meets the requirements here. So then it's going to return, and we're going to do this part, which is from 0, 0. Now we're going to subtract -1, which now means that we're going to be here outside of the boundary. And again, that one's going to be skipped. So we're going to return, and now we're going to go to the next one, which would be I, and then we're going to do j plus 1. So I0, j plus 1, which would be 1 now. And we know that 0, j1 is land. And since that's the case, we're going to go through this here. This is all going to be false. And now we're going to mark it as 0. And then again, we're going to go through. Now we're at j, and we're going to add 1 to it. So now it's going to be 1, 1. So we got 0, 1, 1. And that's also land. So we're going to mark it. So once we're done with the first iteration of these, we're going to end up having these guys already marked as 0. And then, as I mentioned, we're going to mark this one. Once we get to this one, we're going to mark this one. And now we found the island here. And we're just going to continue doing that until we completed the island, which in this case, everything else, since we already found all the island here, is going to be 0. So now we're going to exit out of this loop, or at least out of this depth first search. We're going to go back here, and we're going to continue scanning the grid after finding the first island. As visited, continue traversing the grid, and then we're going to find the second island, which is going to be here at, so we got 0, 1, 2, 0, 1, 2. So we find the second island here, and we're going to explore all 4 directions in the same manner. And in this case, there is no island that is either horizontally or vertically. So we're not going to have to do much depth first search in that case. And now we're going to go to the next island once it's done here, and we're going to find 3, 3. So 0, 1, 2, 3, 0, 1, 2, 3, and we found this guy. And we found an island there, and we're also going to explore all 4 directions as well. And first thing is, if we do as we did before, where we check all the boundaries are all going to be false. So now we mark the land that we found here as 0. And then we go to I plus 1. So 3 plus 1 is 4. Since that's going to be 4, we're going to be out of bound. So we're going to skip that. And then we're going to return. We're going to have here 3 minus 1, which is going to be 2. And it's going to be here. And we know that's water, so that's going to return as well. And then we have 3, and then 3 plus 1, which is going to be 4. So we have 0, 1, 2, 3. And we also have 0, 1, 2, 3. And now we're going to add 1 to it. So it's going to be 0, 1, 2, 3. So we're at 3, which would be the row. And 0, 1, 2, 3, 4. So row 3, column 4, we find land, which is where we're at here. And we're going to mark that as 0. And then we're going to go again here, which would be plus 1, which would be the same thing. This is going to go out of bound, and it's going to return 0. It's going to return out of bound, which is one of these boundaries here. Which is in this case the row. It exceeded the row length. So it's going to return it, it's going to skip it, and now we're going to go here to actually here, which would be -1. We already did this one, which would be up. Actually, no, we didn't do this one. So we're going to go up here, and we know that that's water, so it's going to return as well. And then we still got 3. Well, we got 3, and then 4 plus 1, which would be 5. And again here we're going to be out of bound over here, so it's going to meet one of these and we're going to skip it. And then finally we're going to do this one, which is 3 and 3, which is where we started. And since that's the case, then we get out of the loop, and now we're at 0, 0, meaning everything here has been marked. And we also go back here where we end it going through all the array, and now we return the number island. As we can see here, it's going to return 3 because we got 1, 2, 3 islands. So alright, now let's explore the breadth first search BFS approach for solving the number of island problem. Unlike DFS, which goes as deep as possible before backtracking, BFS explore the neighbor first, level by level. This makes BFS more suitable for scenarios where you need the shortest path or to avoid deep recursion. This visual representation helps us understand how BFS explore nodes level by level compared to DFS, which goes deep before backtracking. So let's explain here, just as we said before. The depth first search just keeps going down all the way to the left, in the inside, to the right, and it just stays on the inside in this manner. So it just traces the tree. And then the breadth first search just follows the ABC manner. To the left, and it stays on the same level, then it goes to the next level. Once it finishes the same level, it goes to the next level in that manner. And in this case, the breadth first search uses a queue, whereas the depth first search uses recursion. So once it finds F, or let's say land, it puts it in a queue. So in this case, it's going to be first in, first out. This guy was in, and it's going to be the first out. All right, now that we understand the concept, let's implement the BFS solution. So we're going to keep some of the code such as this, because this is not going to change much besides calling it, instead of DFS, it's going to be BFS. And this is remain the same as well, because if the grid is empty, we're still going to return 0. So it's going to be BFS. Now, since we're going to implement the queue, now this is where we do X, Y instead. So we're gonna change here, let's say Q, and we're gonna DQ I and J. And we're gonna do a while loop in order to go through the queue until it's empty. Just to make sure I don't make any spelling mistake. And now we're gonna have an X and Y. And here, as I said, first in, first out. So when we find an island, we're gonna put it into the queue, and we're gonna run here until we run out of queue, meaning the first, there is nothing in the queue. But here, starting out, we're gonna DQ. Let me put some battery. So we're gonna DQ here. And just so I don't have to misspell it, then I'll pop left, which takes out the first item that was placed in it. And here the boundary stays the same that we're looking for. And now instead of returning, we're just going to continue. Since we're not doing any recursion. So that just, when we do continue, it just means that everything that goes after it is going to be skipped as well. So this is going to stay the same as well. We're just simply going to change the coordinate system. Instead of X, we're going to call it, instead of Y, we're going to call it X and Y. Instead of IJ, we're going to call it X and Y. So the grid will stay the same. And here, this is where this changes. So instead of doing recursion, we're just going to use Q. And we're going to append the specific values. And the distinction here too is that we queue it this way, or we append the value this way. And again, we're going to use X instead of Y, and Y instead of X, and instead of J. So let's use this. And again, instead of up and down, what we're doing is we're just appending it to a queue. X and Y. X and Y. X and Y. This is X. This is Y. So now we're no longer going up. I mean, we are still looking up and down, but we're not doing recursion. All we're doing now is we're doing a queue now. So first in, first out. So the island is still 0. We're still going through the same range here. We're still going through the loop. We're still finding an island. We're going to increment the island before we find it. We're going to do breadth first search with I and J. We're going to return the island once we find everything. We're still looking at, so it's going to be BFS now, breadth first search. The Q, we're going to DQ. We're going to continue to iterate through it. And let's just make sure this right here is inside my loop. So now we go through it. We find if any of these are met, such as being outside of a boundary or it's water. If that's the case, we're going to skip. If it's not the case, if everything here is false, then that means that it's land, and we're going to mark it as land. And then we're going to append starting from whatever index we're currently at, and that's how that's going to work. Let's see if there's any issues. Okay, so Q append, I forgot to use this. Okay, so I got the wrong answer. So let's see why. Okay, so I got this here. BFS IJ, IJ. So this is correct. And then let's see, DQ looks good. And then we got Q, QUE, UE, QUE, QUE, pop left. And XY, we're checking the boundaries. Here. So the issue is I forgot to change them to X and Y. Okay, so let's see that. Okay, so this one was accepted. And here, this one's 2027 millisecond with 2781. So let's see if it beats it. Okay, so this one's a little slower in millisecond, but better in memory. So both, as you can see, are effective. It just depends on how deep the grid is. When it comes to recursion, that'll be the worst the deeper the grid is, and breadth first search would do a better job. Okay, so let's go through an example problem to see how the BFS solution works in practice. So we check if the grid is empty. In this case, the grid is not empty, so we proceed. We initialize the island to count to 0. This will keep track of the number of islands. Traverse every cell in the grid using a nested loop, using the outer and inner loop, as we mentioned here, which is what we did before. And then first land is found as 0, 0. So we increment island to 1, and then we now go to BFS, which is where we're going here. At 0, 0, we're going to DQ into Q. So now Q is not empty. Then we're going to check for boundaries. Once we pop left, and we know that this case is going to be land, so we're going to go and mark 0 as visited, setting it to 0 here. And to avoid revisiting the same land cell, this prevents double counting of island. Then we're going to NQ all 4 directions, which will be down, up, right, and left, as you see there. And then grid after exploring from 0, 0 is going to look like this. So once we explore 0, 0, the grid looks like this. So now the Q will contain 1, 0, which will be here, 1, 0, and it contains 0, 1. So then BFS is going to visit 1, 0 first. So we're going to DQ it. We're going to DQ it here. It's going to be false for everything here, and then we're going to mark it as 0. And then we're going to do the same thing. We're going to Q everything to the bottom, to the right, to the top, and to the left. And this one will be skipped because it's 0. This one will be skipped because it's out of bound. And this one will be stored in the queue. So we'll have 1, 1. And then once that's done, then we're going to DQ again. And we're going to DQ 0, 1, since that's the one that we did not go to, which would be here. Here. So, and that's going to NQ this, which would be 0, so it's going to be returned. And it's going to NQ this, which is out of bound, so that's going to be skipped as well. It's going to enqueue this one, which is 1, 1, but that's already accounted for. So it's not going to be added to the stack. So now, once we did that, we now visit 1, 1, which is the last one remaining in the stack. We're going to dequeue it here. We know that it meets, this will all be false. And then we're going to convert it to 0 to show that we visit it. And then we're going to do the same thing. We're going to look in every direction, which we already have these as 0. So we already marked this as 0. And we marked this as 0. So now we're looking in every direction. They're all 0. So now we're going to mark this as 0. Now we have all zeros. So now we're going to go back to the loop. And now we find our second land, which is going to be a 2, 2. And once we get here, again, we're going to enqueue here, enqueue here, enqueue here, and enqueue here. And all of these will be skipped because they all meet the criteria of being 0. So then we found our second land, and now we go to our third land. So once we find our second land, everything becomes 0. So now we're at third land here. We increment it. So we went back here, we incremented it again. So now we got 2 land, and we call BFS again. BFS is going to dequeue 3, 3. And now we have something in the queue, and it's going to give us the coordinate when we pop left, which would be in X and Y here, which we originally enqueued here, or dequeue here. And now the boundary is false here again. So we're going to convert that to 0, in this case here. And then we're going to append again to the right, to the left, which would be down, to the right, up, and left. And it's going to be skipped here, it's going to be skipped here, it's going to be skipped here. So we're going to enqueue here. And when we enqueue there, then we're going to move to, then we're going to dequeue. Again, we're going to pop left. And then we're going to know that there's a 1, and that specific item is going to be marked as 0 as well. And then we're going to end up here. And then we're going to come back, and we're going to have 3 islands already. We exhausted our array, and then we're going to return 3 islands. Let's compare the two approaches. The DFS approach is easier to understand if you are comfortable with recursion. It fully explores each island before backtracking and uses a recursion stack to keep track of visited nodes. However, this results in a higher space complexity of big O of m times n due to the recursion stack, especially in very deep grid. The BFS approach is more space efficient because it uses a queue to explore nodes level by level, avoiding deep recursion. The space complexity is big O of min m over n, so whichever one is less, m or n, making it more suitable for very deep grid where DFS might cause stack overflow. So the time complexity is both DFS and BFS have the same time complexity of big O of m times n, as every cell in the grid is visited exactly once. However, BFS is generally faster in practice due to the lack of recursion overhead. So when to use which approach? Use DFS when the grid depth is not too large, avoiding stack overflow. You prefer a recursive solution that fully explores each island before moving to the next. And use BFS when the grid is very deep, as BFS avoids deep recursion and potential stack overflow. And you need level order exploration, which BFS naturally handles. So both BFS and BFS are correct and efficient for solving the number of island problem. The choice between them depends on the grid size, shape, and performance requirement. Here in LeetCode, you're not able to see the distinction since the problems are so small, but in a bigger bore problem, you will. BFS is generally more space efficient for large and deep grid, while DFS is simpler to implement using recursion. And this chart here shows you the difference. Same time complexity, whereas in this case we have the green, which would be BFS, has greater It'll be a better choice if you're trying to save space. So that's it for today. If you found this helpful, don't forget to like, subscribe, and hit the notification bell to stay tuned for more coding insight. Drop a comment. If you have any questions or suggestions, see you next time.